Hey guys, in this video we are going to learn a concept called as typecasting. Now what is typecasting? Typecasting is a mechanism that converts a data type into another data type.
Alright, so we learned there are 8 primitive data types available into Java.
And now we are talking about how can I convert one data type into another. But why do we need to do so at the first place? Isn't it? So guys, that's a very valid question, and every technology exists for a reason. There might be some problems in the past which are being fixed by typecasting. Alright, so let's take an example of this method. This is a very simple method which just takes an input from the user and add 5 to that. So for example, if you have passed 10, it is going to add 5 to that and returns you what? 15. Very simple, right? Now guys, the thing is, if this method is consumed by multiple parties, and take an example of APIs, if you guys know what APIs are. Now APIs are built so that they can be consumed by wider range of audience. And when that happens, you have lesser control over what users are going to pass to you. Okay. So a user in this particular case, right, can pass us the fractional number or the whole number. So we have no control over that. And also how big the number they are going to pass, we have no control over it. All right. So taking all that into consideration, we said that double is the largest possible number in Java. Okay, so double can hold any number. So we said, okay, let user pass anything, and double is able to handle that number. Now, what we want to do is, once we have this number with us, we say, okay, I just want the whole number from this number. If user is providing me the fractional number, I'll just remove that fraction part and I add 5 to the whole number. Now I can save whole number into my database despite of whatever number that user provides me. Okay, so this is where we require typecasting. Okay, so guys, we know what is typecasting. All right, now there are two type of typecasting in Java: widening casting and narrowing casting. Now widening casting is done automatically when passing a smaller size type to the larger size type. It is also known as implicit conversion or casting down. It is done automatically. It is safe because there is no chance to lose data. It takes place when number one, both data types must be compatible with each other. Number two, the target type must be larger than the source type. Okay, so if I say this is my source and this is the target, then byte can easily accommodate into double. Same ways, int can be easily accommodated into long, float, and double. Now, how can you remember this? So you have to remember the size, guys. Okay, so 4 bytes can go into 8 bytes, and 4 bytes are equal to 4 bytes. And same way, this 4 bytes can go into 8 bytes again. Okay, and that is the very reason they can easily be accommodated into the other data types, provided the size of the target data type is greater than the size of the source data type, and they both should be compatible with each other. Have you observed, guys, that we do not have the boolean data type available in here? The reason is obvious, because boolean stores what? True and false. Now how can we convert true and false into either numbers or characters? Hence we can say that boolean is not compatible with these other data types. Then guys, the next thing we have is narrowing casting. So converting a higher data type into a lower is called as narrowing casting. It is also known as explicit conversion or casting up. It is done manually by the programmer by placing the type in parentheses in front of the value. If you do not perform casting, then the compiler reports a compile time error. In this method, this is narrowing casting, and I've explicitly done this, as you could see. So in the parentheses, I have provided in the data type in which I want this thing to be casted. Okay, so let's see some examples. So guys, in the previous video we learned the syntax through which we declare and initialize our variables. There is one more way which I'm going to introduce to you in this video. Now you can either set it to some value, alright, or what you can also do is you can say num int. Now what will happen if you do so? So whenever you mention this variable, it is going to read the value from the memory and assign the same value variable. Okay. Now there is a concept called as call by value and call by reference, which we are going to learn in a separate video. But for now, in memory, there would be two variables created and both will carry the same value. Okay, something like this. So numInt will point to a memory address which will contain value 10 and numLong will also contain the value 10, but these would be stored at two different addresses. Okay, just remember this. This concept is confusing to a lot of beginners, but I hope I have made this clear to you. If you would have been working in Python, then this and this would point to the same memory address. But in Java, they point to the different memory address. So same way we can assign numInt to this. Okay, we have integer which can easily fit into long, and this integer can also fit easily into double. Okay, so if you run this program now, so you would see my int is 10, numlong is also 10, because remember these are whole number data types, and in here you would see 10.o. Okay, let's run this. Right, so you see my int is 10, numlong is 10, and numdouble is 10.o. Alright, now let's look at an example of narrowing casting. So in here we have double, and we are narrowing it down to long and int. So we got to do the same as we did above. So we just have to say my double. Okay, but guys, we have an error in here. Alright, like I mentioned, we have to add cast to long. Okay, so you have to explicitly mention that. Okay, like so. Same way, if I make an attempt to do this with int my double, right, again you would get an error. So you have to add int, okay, like so, and this is called as manual casting. Okay, now we can uncomment this section as well. All right, what do we see? So we have 10.10d in here. Okay, now long will contain 10 and int will also contain 10, because these are what, whole number data types. So there is a problem with narrowing casting, guys. We lose data, and we can lose that in two forms. Number one, in this example, okay, we'd lose this fractional part. Okay, and let me show you the another one. So I just say double and test is equal to, and I provide a big number like so. Okay, double can hold that. Now I say byte, okay, and test1 is equal to, and I set it to test, and of course I have to do the casting, implicit casting, so I just add byte in front of it. Now guys, if we log this test1, then see what will happen. Test1, okay, so let's see that. So let us run our program. So you could see test1 is -1. Okay, so this was my original data, right, and I have typecasted it to byte, which is the shortest data type available, and it has converted this value to -1. Okay, so be very careful when you use the narrowing casting. This is one example wherein this works perfectly, but You have to use the data types very wisely. Okay, in this particular case my requirement was to get rid of the fractional part. Now guys, the thing that I've taken care of is that this takes in 8 bytes. Long is also 8 bytes, so I'll only lose the fractional part. Okay, if I would have used int is of 4 bytes and this is of 8 bytes. So this problem would happen if I would have used int in here, and therefore it is very important to remember the range and the size of these primitive data types. So I hope you like this. I'll see you in the next video.